Perfect. Yeah, so I'd like to talk to you guys about components to helmets, building augmented reality systems for motorcyclists and for the racetrack. I'll mainly be focusing on our motorcycle use case. Just quickly about me, I'm the CEO and founder of Aegis Rider. I'll be talking quickly about Aegis Rider itself, how we got started, then talk about our process of what it takes to actually build such a product that works for the motorcycle industry. Talk about our rigorous user testing, because that's very, very important. We heard it this morning. You know, customers key. Talking to customers early is vital, especially if you're building something that doesn't really exist at the moment. I'll talk a bit about our system itself, so our advanced heads-up display in action. Talk about kind of our key features that we have, which include our low latency tracking in these dynamic environments. Talk a bit about our industry and end with a roadmap. So I'd like to start quickly by just giving a bit of background on Aegis Rider. So we're a Swiss startup out of ETH. It's a technical university in Zurich. On the picture here, you see my 3 co-founders and myself. So the project actually started out of the computer vision lab. I previously did my PhD there in computer vision, and actually the whole, let's say, company itself is more focused on the software itself. So enabling, the software technology, the tracking, the low latency rendering, and then we are more of system integrators. So, we're relying on you guys to provide us with optical modules that we can actually fit and integrate into this particular use case. I'd like to start by basically outlining, the 6 kind of main points that motorcyclists tend to look for. So, as a motorcyclist, I don't know if there's any motorcyclists here in the room. Maybe a quick show of hands. Anybody? A couple. Okay, great. So, as you know, we're vulnerable road users, and taking your eyes off the road to see information is one of the most, let's call it annoying things that happens, because on the one hand, you're reliant on information from your bike, such as your speed, your RPM, maybe navigation. But compared to cars, and depending, of course, on your motorcycle model, the display of your motorcycle is actually quite far down compared to your car dashboard. So in the car dashboard, maybe you're refocusing maybe 10 to 15 degrees to see information. If you're sitting on a naked bike where your display is down there and you're looking forward, you're looking down up to 60 degrees to see information. So motorcyclists want an unobtrusive kind of display, and technology has been put on the market where you had a monocular kind of heads-up display that was head fixed, so information was always spatially anchored to your head, and this, as a motorcyclist, is actually very distracting. So what we do is we actually anchor information spatially in 2 reference frames, one being the motorcycle. So this means that, similar to your car heads-up display that you might know, where when you're scanning for hazardous objects, you're scanning for pedestrians, other cars, that HUD stays in front of you and does not occlude or block any object that you might want to see. We do the same thing with our technology. So we're localizing the helmet relative to the motorcycle in real time and allowing the ability to anchor content relative to the motorcycle. So the heads-up display always stays in front, and paired with the vehicle localization module, so think of like a GNSS INS system, we can also anchor information in space. So that's actually crucial, for example, for navigation. You have navigation arrows appear at the intersection. On racetrack applications, you can show your ideal trajectory and stuff like that. I'll go a bit into more detail on how we solve this in the upcoming slides, but that's mainly one of the main points. The second thing is you want your optical system to actually not have any, like, zero distortion, any kind of artifacts coming from diffraction. Magnification, minification is sometimes an issue with certain optical modules that are available, so you want to have as least optical distortion as possible. Then crash safety is, of course, very important. All of these helmets in the end are there to protect your head in case of an accident. That also applies to the optics. So if you're using a glass substrate for diffractive waveguides, for example, you either make sure you have very good encapsulation so that these don't shatter and pierce your eye during an accident, or you need to look for other types of technologies that enable that. Form factor is also critical. People wear their helmets, differently. Some pitch it up, pitch it down. So You know, you can of course get very advanced